Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today's topic is unique physics concepts, how to promote the science by Vahan Davoudian, physics experimentalist. And this is my email, vahandavoudian1948@gmail.com. And in fact, today we are going to talk about general relativity. I published this in July 2022. It was great success. It was 4 parts. You can watch it. And today we will analyze more. And I'm glad that it was great success. So many people emailed me. They loved it. Even university professors, some viewers. Anyway, I am physics experimentalist for 30 years. First of all, I would like to thank YouTube for wonderful opportunities for uploading our science videos. Latest technologies and science concept. We can connect with many viewers, exchange views, and learn. YouTube is like a huge network and university. I call them synapses in human's brain, connecting billions of neurons to transmit information and charges. YouTube is the key to learn. Many viewers emailed me and loved my science videos. It was great encouragement for me to upload more theories and experiments for physics enthusiasts. My theories and experiments are unique. I have never seen in any physics books. All of them are substantiated with experiments. I have already uploaded 40 theories. You can watch them on YouTube. As a token of appreciation, I would like to thank everyone for supporting me. Your feedback is extremely important. I do honor them, any suggestion, any adding, or any concerns. My inspiration came from sports, nature, animals, and insects. Today I have very important and generous proposal for physics and science lovers. Any college or university want me to come to you, I will be honored. I will pay for all the expenses. I can even bring some experiment for demonstration. I have 40 more theories. I will upload them every week. I finished my theories by year 2000. I have had many lectures in physics and in Regis, DeVry, and CU Boulder universities for physics students. I will be able to highlight some of these theories briefly because they are 20 hours experiment. In laws of physics must be 100% thermodynamically enclosed system. In fact, my inspiration came from Niels Bohr because he was an amazing physicist and he compared the electrons, and because his model of atom was one of the best. Neutron, protons to solar system, and always I remember I'm following his footsteps. He was a great scientist. And in fact, in all these 30 years, I tried to replicate so many experiments as much as I could, because some of them I couldn't find the material, some of them it was beyond my expertise, or I didn't have the tools like, superconductivity, I didn't have the liquid nitrogen. But overall, I did as much as I could, from Michael Faraday to Galileo especially, which was the great success, and it was called the theory of free-falling object, so you can watch them. This was published 10 months ago, last year, and that was great success. It was 4 parts. But today, this second one is the 2 of 3, which is for the general relativity. Of course, there is no doubt Albert Einstein was one of the greatest scientists in the world. But I have to clarify something. When he was born, the road was clear, the stage was set. I'm sure if I go in the streets, I ask so many people, who did the general relativity? Probably most people would say, yeah, Albert Einstein. Even if I go to colleges, probably they will be the same answer. But I had to go back 500 years. That is amazing. That is not Albert Einstein where it started. It started with Copernicus. Probably you know about the Copernicus. He was the great astronomer. He was the great scientist in the whole world. I mean, there is no way his contribution to science changed our perception. What Copernicus did before him, they were thinking that the Earth is the center of the universe, but he changed everything. and then he had to swap or change Earth with Sun, and the mystery was solved. And he said one very profound sentence I always remember. He says, our perception from the universe, it depends on where we are. And then when I was watching the eclipse in Portland, Oregon a few years ago, I remember what Copernicus said. He was absolutely true. That what he said, it is absolutely true. And you know, you have to be in totality to see the solar eclipse. You must be there to see the 100%. If you're a little bit away, you can see 98%. I was in Portland. I was almost like 10% off. So we did see 100% almost, but you know, it wasn't. But some people were a little bit further from the Portland, they saw 100%. So what Copernicus said was absolutely true. And I'm sure people would not mention Galileo. He started the relativity. Galileo probably was one of the greatest scientists in history, because the way he discovered the pendulum, and then he improved the telescope and everything else. And imagine his contribution to science was amazing. Before Galileo, we had no idea how the laws of motion work. And he was so genius. In church, he found out that the chandelier was going back and forth. Probably billion people, millions of people have seen in Italy the chandelier was going back and forth. They never thought about that, why it's going, swinging back and forth. He was in medical school for 2 years, and then at that time, 400 years ago, there was no clock, there was nothing, but because he was genius, he took his pulse, and then I realized that a small arc of the pendulum, or that chandelier, takes the same time. So Galileo's contribution to science was so good, and before and after him, Sir Isaac Newton came in, the stage was set, and then Albert Einstein came, everything was set. But Galileo said, if this is the relativity, one thing is stationary and one thing is in motion. And Galileo set the stage. He said, you have to have the frame of reference. And he proved that, relativity starts, you have to have a frame of reference. Relativity means always you're comparing something. One known with one unknown, and then you find out where the problem is. And I'm sure nobody will mention Fitzgerald, nobody will mention Hardy Pointer and the other people. Why? Because Albert Einstein was an amazing person. He connected the dots. And in fact, this is my term. And then I coined this term. I called Albert Einstein synapse. In human's brain, synapse is like a junction, and then it's connecting billions of neurons everywhere. He was extremely smart, and always he was corresponding with so many people. At that time there was no email, nothing, it was all with mail, but he was smart to make all those dots connect them together. And when I analyzed his life, I realized Albert Einstein was the great scientist, but when he talked about the free fall, there was one thing that I didn't like it, and he was in a patent office. He was looking out the window, and then he saw it was just the imaginary thing. He thought, what if someone is falling? It was the opposite building, and he or she is not going to feel its weight. It's going to be no weight because you're free falling. Well, that's absolutely true, and I even see some science videos that somebody is sitting on a scale and free falling, and it's not showing any weight at all. But there's a point here. That man is on the scale is showing 9.82 meters per second square. They are falling at the same rate. But Albert Einstein missed this part. He did not mention that the laws of inertia is not an equation. That is why you are not feeling your weight. And then I had to analyze and reanalyze. I said it doesn't matter if you're in a gravitational field, like surface of the earth, you're in a train. The train is moving smoothly. I mean, 60 kilometers, 100 kilometers, you don't feel anything. As soon as it changes the acceleration or deceleration or left to right, you can push back and forth or up and down or, front and back, because that is the way things works. If you don't have that inertia, you will not have any weight at all. Now think about that. If I weigh something practically, it is not a good say to weigh. I'm weighing or I'm measuring the acceleration. I put 1 kilogram apple on the scale, I am measuring 10 Newton force. So in other words, I am calculating the acceleration due to the gravity to the center of the earth. But if I don't put it on the earth is not pushing on it, it's not going to show anything. So it's absolutely right. If you are free falling, it's not going to show your weight. I mean, you don't even have to mention that. Anyway, and then I analyzed and reanalyzed that, I said, it doesn't matter anywhere, because Galileo and Newton said something profound and so important. They said laws of physics works in any inertial frame of reference. And that's absolutely right. Even if I go in a space station, it doesn't matter. It doesn't have to be around the sun's orbit. The space station does the same thing. People astronauts inside the space station are free falling. And the space station is free falling. That's why you can see, they cannot eat exactly. If they push something, it's not falling like Earth. That's absolutely true. But if I'm an astronaut, I'm 80 kilograms, I won't be able to weigh myself. They have to strap me on a special device, and then they accelerate me with the known forces, and then you can tell, yeah, I am 80 kilograms. Because see, everything falls at the same rate. You're not changing the acceleration. Anyway, I had to do so many experiments, and this was one of them, and this is called accelerometer. And this is amazing device. And it's got like 3 axes, X, Y, and Z. And imagine if I drop accelerometers, which the precision is 100%, it's not going to show any weight, because the laws of inertia is not in equation. But as soon as I put the accelerometer on the surface of the Earth, it's showing upward force 1 G or 9.8. So this was my idea, and people love this in CU Boulder, and they appreciate what I did. This was a hypothetical, not hypothetical, I would say, thought experiment, and they love this idea. I said, if I am on like 100 meters height on a cliff, and I have a bungee cord, I'm strapped exactly, and when I fall, my glasses are falling with them, my watch is falling with me exactly at the same rate, and I can tell it might take 1 or 2 seconds or 3 seconds, they all fall at the same time. I said, if I'm on bungee cord and then I fall, but it must be synchronization, must be 100%. Some people are not on bungee cord, but they're here, they can adjust everything. Simultaneously, they release 1 kilograms and 10 kilograms. Vahan is falling with a bungee cord, 100 meters almost. I can push the 1 kilogram, it's going to go easy, but there is a point here that 1 kilogram has inertial mass. It doesn't have gravitational mass, because see, it is free falling. 10 kilogram also has the inertial mass. If Vahan pushes on 1 kilogram, it needs less force. 10 kilograms, I need more force. And then I came up with this idea. But this is extremely difficult experiment. If I have a scale, and then I have a thread or a string connected to that scale, and I have like a 200 grams on the scale, it's free falling, it's not going to show. As soon as I'm jumping here, I pull the string, this is also free falling. And momentarily, that scale, electronic scale, will show 200 grams. The reason why I'm changing the rate of acceleration. And people love this idea. I said, this is a good idea, and I'm hoping that, what they said that you don't feel your weight is obvious, but you have to change the rate of acceleration. And this was amazing. Experiment. I did it in John Crane International. I used to work in Golden, Colorado, and then we had a warehouse was like almost 20 meters high, huge building. So I could do all my experiment there, and then I had free time, and then it was in Golden, beautiful city, historical city. And this is what I did, and unfortunately I did not make any movies, or I did not film this. Earth is not causing any torque. Let me show you. Earth is not causing any torque if something falls like this. So I thought, what if I change the orientation? So I dropped from like 15 meters, it would take maybe less than a minute, but I could watch. I was on a huge ladder. I dropped like this. This was horizontal from my perspective. It went down all the way horizontal. I tilted a little bit like this. I dropped it like maybe 45 degrees. It was going exactly 45 degrees, hit to the ground. But this was an amazing idea, because I thought that the Earth is not causing any torque if it's in free fall. And this was another groundbreaking idea that I came up because, like I said, most of my ideas came from sport, nature, and animals. And basketball is my favorite sport, soccer, and basketball, and volleyball. And then I came up with this idea. We have two basketball players. And the humans, their ability is not exactly like animals. We cannot jump like cheetah or the other animals. They can jump maximum, the best players in the world, in the United States we have the best basketball, 1.2 or 1 meters 20 centimeters, maximum they can. And I recalculated with great precision. I realized by the time they're at a free fall, it's almost 1/3 of the second, which is a lot. And then I realized one of them, number 5, is 180 kilograms, and number 15 is 120 kilograms. By the time they are at the 1 meters 20, if they push each other, the 180 kilograms is not going to be accelerated exactly the way 120 kilograms is accelerated. So 1.2 meters, and this one is accelerated 1.8 meters. And then I had to go back to a space station. It was the same thing. I mean, you don't have to be a basketball player, because this is a short time. 0.3 seconds or 1/3 of the second is extremely short, but you can see. But in the space station it's easy. You can have two astronauts join their hand together and push each other, and you can tell if Susie is 80 kilograms and John is 100 kilograms, John is not going to be accelerated exactly like Susie. Susie is going to be accelerated more, and John is going to be accelerated less. So the way they drift apart is to the inverse proportion of their masses. Well, of course, this is another one. I mean, you can tell this is so obvious. Let me take this down. This is so obvious. This is on a gravitational field, and then you can tell. See, we have Angela, 80 kilogram, and John, 120 kilogram. They have roller blades, and then it doesn't matter. They are both. Angela is pushing on her on 80 kilograms, and John is pushing 120 kilograms. It doesn't matter, they're both the same. because they have less friction over here. They can push each other. So Angela is going to be accelerated more, and John is going to be accelerated less. And that is obvious that, always has to do with this. This was the best moment in my life because what I experienced, this was the great moment in my life. And in 1994, I was in Universal Studio, and then I invited so many guests, my kids and so. And we were so lucky, we got a ticket for Universal Studio, and especially I wanted to see Back to the Future, because I knew about that, I read about this. When I wasn't 100%, it was a little bit foggy in my mind. I wanted to see how that works. And it was amazing coincidence. Miguel Alcubierre in 1994 came up with this idea, which was breakthrough in science. He said, there might be a day we will have a spacecraft like this. In front is a little bit, in the back is expansion, contraction and expansion here, and the spacecraft is not going to be propel itself. The sides or the background or the space is going to propel itself. I read this for you. Expanding and contracting a space-time that displaces the central region, changing the geometry of space by creating wave that would cause the fabric of space expand and contract. So here is contracting and here is expanding. But amazing, and some physicists analyzed this, even he has some interview with Mr. Michio Kaku, great scientist. But if this comes true, that will be like a wormhole. And that's exactly what happened to me. And this was a great moment in my life. Let me put this up so you can tell. You may not believe, I have watched this, Mr. Michael J. Fox was so young at the time. This movie maybe is 40 years old, or at least I would say. Maybe I have watched this 100 times. So I like him with that fuzzy hair, and I call him second Albert Einstein. This was a great moment in my life because it never happened in my life. So we were there, and then we were waiting for the, to open so we can ride that back to the Future. There was an old man, he passed out because there's a big sign showing if you have a problem with the heart, you're not supposed to ride. But somehow he did it, and then they were so lucky they stopped it immediately, and then they just released him, but he was not harmed, he was okay. And I don't know why I got so lucky. I was there where the cart was, and then I realized the cart is not moving. The cart is swaying left to right, and then up and down, front and back and forth. But the thing is, the sound is so synchronized, and you have optical illusion on both sides, so the space is moving, you are not moving. But it was so real, I thought, wow, this is going to be amazing. By the time we wrote, like I said, like Albert Einstein, I told myself, Vahan, this is a great moment in your life. Honest to God, in a few seconds or maybe less than a minute, I realized I entered from one universe to the other one. I went through the wormhole. I realized I entered new dimension, and that new dimension was so good. I knew for the fact that this was optical illusion, but I said, no, Vahan. And imagine we were going on a lava tube, and then that cart was hitting those, big clock, everything was smashing, but the synchronization was 100%. I have never seen such engineering in my life. And then I said, Vahan, this is amazing. This is general relativity. If this comes true one day, we will be able to beat the speed of light Who cares about the speed of light? We can beat that. So for a few seconds, I went through the wormhole, and then when we were back, I had to go home, write so many things. And this was, my highlight of the general relativity. Like 9 months ago, I did it, and the people loved it, and they loved this comparison. And I appreciate Mr. El-Kibiri that he came up with this fantastic theory. And this was another thing that I want to demonstrate. This was another breakthrough in science, but unfortunately, it doesn't happen so often in a solar system. He was English pilot. It was in 1970, and he was 22 years old, and he was flying with two more, friends, and it was in Bermuda Triangle in 1970, and his name was Bruce Gurnan. He was a good pilot, but that small airplane was not capable of traveling fast. And then he had so many, books. He published a fog, and he became a famous person. This happens before, but unfortunately, I don't remember that pilot's name. That was way before 1970, and then he was flying with a small airplane, and then he got caught in a vortex. The vortex was negative charges, negative energy, and everything was out of control, malfunctioning. The gyroscope and the compass and everything. He said we had no control over the airplane. So he was not propelling with his propellers or, action, reaction, or thrust, or anything. That vortex was pushing him forward, and he had no idea. Instead of landing in Florida like in 1 hour, he landed in 20 minutes. It's beyond our imagination how a small airplane can go that fast, because that tells you something. The space of time has nothing to do with this. I came up with the idea, I will explain it in third part, that the entire concept of the gravity is electric charges. Well, of course, I do honor the existing theory, but he proved, Mr. Gurnan, that space of time has nothing to do with the gravity. That vortex, that negative charges were propelling him, not the gravity. This is another poster, which I like this one. Probably he was the most important scientist, like Michael Faraday. He was great experimentalist. How could you be 70 years old and do experiment like this? Because Henry Cavendish was amazing English scientist, that he discovered so many things. But I don't know why he did this experiment 29 times. I don't know. But he was so meticulous, he was so good. And in fact, it was an English geologist who started. The poor man died, and then he had to take over. He was an honest person. He said, I'm not going to get the credit. Mr. John Mitchell is going to get the credit. So he did it. I mentioned a few minutes ago, anything has to do with the laws of thermodynamics. Anytime you have any experiment, it must be 100% thermodynamically enclosed system. If I have a pendulum, we have air drag, we have the friction, and some other things. But you know what? We're not going to get 100% the result. But Henry Cavendish was extremely smart person. What he did, he had 158 kilogram lead, and we had 730 kilogram smaller one. So his idea was, if they're suspended in a closure like this, and they might be able to attract each other. That's exactly what Sir Isaac Newton said. F is equal to G m1 m2 r2. And when Sir Isaac Newton came up with this formula, that was amazing. No one had done that before, what Mr. Henry Cavendish did. So he had to put everything in this closure, and he was extremely smart. There was no air, there was no wind, there was nothing. It was 100%, well, of course I have to mention, it was not vacuum. But there was no outside influence. He had to look from here with the telescope, so even his air breath, it would not do anything. After a few minutes, he found out that, the small sphere, which was 730 kilograms, is attracted to the big one 4.1 millimeters. 4.1 millimeters in physics is astronomical. It's amazing. When I divide this, you can see 158,000 grams divided by 730 grams. This was 216 times more. So imagine what he did was proving something. Both of them, 158 kilograms and 730 kilograms, even though they were suspended, but they are attracted by the gravity. They are accelerating toward the, center of the Earth. But why did they move 4.1? It's because of electric charge. And to be honest with you, I love the Charles Coulomb formula for this much better. Q1, Q2 has to do with the charges. But I like the Sir Isaac Newton's one for the bigger scales. Few minutes ago, I mentioned that, Albert Einstein did his general relativity, and he was inspired with many people, like Henrik Lorentz and then Fitzgerald and the others. But this was another amazing idea. Michael Faraday had no education, but he is considered one of the greatest experimentalists of the time. He was so genius. They wanted to get rid of him because he was so good in electromagnetism and everything else. They want to send him to the glass factory. He didn't like it. He was not enthusiastic for that at all. So he brought one home, and then this changed his life. This shows that, he polarized light, and then he had this glass brick, and then this polarized light was going through this. And this is called Faraday's rotation. And then as soon as this, strong magnet was energized, he had an eyepiece over here he could observe. This was changed. This was tilted a little bit. So this was amazing idea for Michael Faraday. This was connection between electromagnetism and light. Like Albert Einstein said in general relativity, the big stars will bend. So this experiment laid the foundation for general relativity. I have never seen any books that mention this, but this laid the foundation for general relativity. This was my idea. I compared a charge. Well, of course, all of you heard about Maxwell, one of the greatest, mind in the history of mankind. I would say after Sir Isaac Newton, probably the second man is going to be James Clerk Maxwell. His contribution was amazing. How he formulated, electromagnetism, which is one of the most important four forces in nature, and that's beyond my imagination what he did. So he wrote a letter to Michael Faraday because he was younger than Michael Faraday, but they were close. They would correspond and so and so. When I compare this with the mass, this one electric charge, when I compare this, I realized what Maxwell did. He also helped Albert Einstein. See, one charge, and imagine those. So this is called like a trampoline. So one charge is warping the space-time. That's exactly what Albert Einstein said. If you have like a huge bowling ball like this. If I put it on trampoline, it's going to warp the space-time. So this is exactly what James Clerk Maxwell did. And you can see the harmony. You can see how symmetrical they are. Well, of course, I have great respect for James Clerk Maxwell because he was great scientist. Now I have to talk about entanglement because unfortunately Albert Einstein was an amazing person, but he had this bad idea or bad habit of rejecting almost everything. And I don't know why such a great scientist would not take things into the consideration, and with no hesitation he hired Rosen and Podolsky. They were good physicists. Niels Bohr was an amazing person, and he proved that the entanglement, his idea was right. But Albert Einstein immediately, he rejected that, and he did not even go to that conference to any, Solvay, and then he did not even go for breakfast, they would not talk to Niels Bohr, but Niels Bohr was right. So imagine after 100 years, this is called entanglement. This is extremely complicated concept. It took like 100 years for them to prove that. If I were Albert Einstein, I would not reject this idea. I would say, well, we have to see what the experiment tells us. But he rejected immediately. He said, if you don't see the moon is not there. Well, it is true somehow, but Albert Einstein was overreacted a little bit. And it took like another 100 years. His name was John Clauser, and then he found that, this entanglement worked. And he proved that with 2 calcium atoms, and then they realized they repeated that experiment maybe more than 200, 300 times. It worked. There was another one. He did it with planets. He was from Austria, and they proved that this was right. So what Niels Bohr said, it was that entanglement works. And here comes another genius. His name was Schrödinger. And unfortunately, there was always debate that, there was a controversy, particles and waves, and then Louis de Broglie came over. He was an extremely brave person. He said, don't worry about that. Particles are waves and waves are particles. So Erwin Schrödinger did this thought experiment, and then he proved that Albert Einstein was wrong. Well, it was a thought experiment. We have a cat in a closed box, and then we have a poison here. If the radioactivity gets there, it will activate the poison, and the cat is dead. Well, of course, there was no cat involved. This is just a thought experiment. If it's not, but this is considered the most important experiment in the history of quantum physics. If we don't open the box, we have no idea if the cat is dead or alive. So Mr. Schrödinger proved this idea, and I'm glad he did it. And I came up with my own idea here. Let me show you. He is my favorite scientist. His name was Ludwig Boltzmann, and he has fantastic formula. S is equal to K log W. So that W means a lot of things. He specifies it means number of the ways the atoms can travel. So it's unknown. And then so many people came after him. It's called probability. So what Albert Einstein didn't do this, He did not take that into the consideration that, Max Born, Niels Bohr, and the other scientists, it's a probability. Because quantum physics is not like ordinary physics. It's so unknown. This is the poster I made. I can demonstrate, you can see. A few minutes ago I mentioned Niels Bohr was my ideal. He was my role model from high school all the way now. I'm 75 years old. I never forget his contribution in science. No one in history has done a model of atom like Niels Bohr, because he explained everything with a great precision. Well, of course, I don't want to make longer. It goes to the lower orbit, emitting photons and so on. So his name was Henrik Kramer. He was an amazing scientist. He had two young students. His name was George Uhlenbeck and Samuel Goodsmith. They were extremely smart. They came to the United States, became university professors. But what they did after Niels Bohr, they said the electron is going in orbit around the nucleus. At the same time, electron is acting like an Earth or Mars. It has plus minus, minus plus, and then they were right. So this was amazing discovery what they did, these two young students. They were like almost 24, 26 years old, but that's what they did. And when you compare it with the planets, their idea is like a planet. It's going exactly the same way. Well, sun is like nucleus here, and the Earth is like electron. It's the same way. Then I came up with this fantastic idea. This was year 2000, and people loved it in CU Boulder. I said, if something works in atomic and subatomic level, can also work in planetary level. Now Mr. Niels Bohr proved my point was right. It can work in atomic and subatomic levels, on both. This was another genius. I have to post this, you can see. His name was Louis de Broglie, and then he was showing here the, how the universe is expanding. This observer number one observer. This is called red shift and blue shift, and this is the way they discover why planets are moving away. And this was amazing person, and when he got his Nobel Prize, he was at the same conference with Marie Curie, Henrik Lorentz, and the others. He came up with this formula: lambda is equal to h over p, and that lambda means wavelength, h is the Planck constant, and the p is the momentum. But he mentioned something amazing. I read that book maybe more than 100 times. It's called Quantum book. You can buy that and then you can read for Louis de Broglie. He said when the electron is going close to the nucleus, it accelerates. That's exactly like the second law of Kepler. Electron is like subatomic particle, but it does the same thing. So he did it. And then there was another genius, his name was Doppler, so he did this also. This is also red shift and blue shift. But I have to mention something in astronomy, which, this was probably the most important discovery of the mankind. It's called spectroscopy. How could you know how the stars are made? Before Miss Cecilia Payne, they were thinking that our sun has like iron, has so many things like Earth, but she was so genius, she got PhD and then was the head of the university, Harvard, which never happened in the history of mankind. So she discovered that, each element and, is absorbing and emitting its own characteristic of light. They call it, it's like a fingerprint. Spectral lines. And imagine, she did it, and at that time the women were not allowed to go any universities, but she did it. And then she proved that the sun, our sun, is made of hydrogen. And how could you do it with this 1.5 million kilometers solve that problem? She was so smart, but unfortunately her professor, Mr. Wallace, was an extremely bad person, and he rejected the idea. After 4 years, he came with the same conclusion, but people knew that, Cecilia Payne was right, and then she discovered something amazing. But before Mr. Gustav Kirchhoff and Bunsen, who discovered these things, his name was Fraunhofer. He didn't have the university education, but he was a lens maker. He did almost 520 or 550, I think, spectral lines. But the poor man had no idea what are those absorption and emission lines. But Miss Cecilia Payne came over and proved that point. There was another problem with Tesla. Tesla changed our life, with alternating current. Tesla had the same problem, but unfortunately I don't know what the professor's name was, because he was fluent in German also. He studied in Austria and then in United States, but he never got his bachelor anyway. It doesn't matter. But what Tesla did was amazing. He was in Budapest with a friend. He stopped. And then all of a sudden, that was the best moment in his life. He said, the reason why we have alternating current, because of changing magnetic field. And then he solved the problem. And he saved the United States in 1930. Most people came from everywhere. They saw the alternating current. See, DC with, Thomas Edison would not work. In a smaller scale is okay. But he saved our life. And he was one of the greatest scientists in history. So this is going to be the part 2 of my part 3. And then I appreciate you're watching, and then I'm hoping you guys can subscribe, and if you have any questions you can email me, and then I'll be happy. And then even if I don't know, even if it's beyond my expertise, don't worry. I'm a big digger. I can dig it out for you, because I'm retired now. I can go all the way to the bottom and find out for you. Thank you for watching.